Hello and welcome back to Precalculus section 2.2 on quadratic functions. So you guys have seen quadratic formula before, you've seen quadratic equations before, quadratic this, quadratic that. Well, now we're just going to say quadratic function. So I can write f of x equals ax squared plus bx plus c. This square right there is the one that says it's a quadratic function, right? Where if you kill this term over here, you just get your y equal mx plus b, right? Which is linear. But with this term back, right, we have our quadratic function. Now there are other forms, right, ways to write this, which we are going to cover better than this, clearly. But, we need to have some starting point. So quadratic function, and now let's go immediately in and look into that better form. Kind of regret that I put that in red up there, but I'm going to actually write this one in red. So f of x equals a x minus h squared plus k, where a is not allowed to be 0. Now that should be common sense, because if you kill, if you have a equals 0, you kill the square term, so quadratic function is dead, right? So you're not allowed to have a to be 0, but that's your quadratic function right there. And let's put this frame on it. And let's take a look at some of these features. So this would be known as the standard form. Standard form. There we go. And some of these features will give you, let's see, h comma k, if you put that as a point, will be called the vertex. And that's always your min or max of the function. So when you graph the function this way, your hk is a minimum. And when you graph your function this way, your hk is the maximum. But now you're going to say, how do I graph? How do I know which way I graph? Well, that's this a, right? So if a is larger than 0, meaning positive, then you have the quadratic function open up. And if you have a less than 0, then quadratic function opens down. So all of a sudden, graphing this becomes a joke.
What does A represent? I don't know if you said it, but I think I missed it.
A is a coefficient, right? That's actually this a that is in front of x squared. And the value of that a will, as we know from 1.6, is going to shrink or stretch the function. But the sign of that a is also going to flip the function, because it is, we also know that from reflections. So this a has a dual purpose with reflections and also stretch and shrink, where the plus k, or h and k, are in charge of moving it left and right and up and down, which is actually what we do next, because we take a look at the example and we see all of those at work. So y equals 3x minus 1 squared plus 4. So the vanilla function is x squared. Now we all see x minus 1. So what kind of a transformation, going all the way back to 1.6, you're going to go pretty much there every class. What kind of transformation is this negative 1?
It goes right one.
Awesome. 1 right. And what's this 4?
It moves up four.
Up 4. Awesome. Now, this 3 is going to do that vertical stretch, or you can also call it horizontal shrink, right? Whatever. But this a is positive. Actually, let's use a different color here so we can make this look really ridiculous. A larger than 0, so I know it opens up. Cool! I can pull my H and K into a point, which is 1, 4, and that creates a point through which I draw the function. 1, 2, 3, 4, and I know it's a minimum, right? Because the graph is going to open up. And there you go. This is a sketch. This is not exact graph because we really didn't do the stretching and shrinking with 3. But at least we know 3 is positive, and because 3 is positive, we know, right, that the graph opens up. So it's very useful, right? And we know it's a minimum, right? We look at it, right? And it's very useful when you have this form. Now, it's not a big deal to go from one form to another. So if you have your 3x minus 1 squared plus 4, right, all you need to do is to square, multiply by 3, and add 4. So you follow PEMDAS to expand this. So that will be 3 times x squared minus 2x plus 1, and you say plus 4, right? And then distribute 3x squared minus 6x plus 3, and then plus 4. And there you go, 3x squared minus 6x plus 7. So it is not an issue at all to change the form from standard form to that ABC form you are used to from algebra. Now, ABC form is still valuable because remember the quadratic equation? Yeah, it's using A, B, and C, not H and K. So you still need to know both forms. But the standard form we just learned is superior form in some sense because most of the time you just want to get a very quick sketch, very quick graph, right? You don't want to go into all of the gory details of everything. And sometimes you need gory details and everything, and then you will use quadratic formula. We're going to do that today. But the thing is that, kind of sense what is that you need, right? Because if you need a quick sketch of a problem, you just go with this and you're done, right? That's how it goes. All right. Moving on to the opposite transformation. So this was one-way transformation from standard to your ABC form, right? Backwards procedure is way spicier. You have to
Can
use
I?
something from intermediate algebra. Yes.
Aren't they both considered standard in one way? Like,
Well, this one is called standard form, right? This one doesn't
okay.
really have a name. We call it
Oh,
quadratic function, right? But I like to call it ABC form because it really pinpoints what I mean, right? If I say quadratic functions, they're both quadratic functions. This one is called standard form, and it should be somewhere in a book as well. The other one is the one that you learn in algebra, and because you need to learn that negative b plus minus square root of b squared minus 4ac, right, over 2a, and you see a, b, c, they're picked from here. So the standard form, unfortunately, is not going to help, right? So we need both.
okay.
All right. It's time to go from ABC form into standard form. Lock the doors. No one leaves. Once upon a time, in your algebra course, you learned something that is called completing the square, and most likely forgot it next day. Now, that is going to be useful in more than one place in this course. So if you have issue with this algebra calculation now, please consult over 60,000 videos on YouTube to get proficient with completing the square. Now, how do we complete the square? You take your quadratic function. You might want to write the notes on the side. You take your quadratic function and you box off, in parentheses, the a and b terms, right? The ax squared plus bx. And if you have a number in front of x squared, you have to factor it, regardless whether it makes it nice or a fraction here. That's beyond the point. You have to kick this one out because in order for the procedure to work, x squared needs to be solo, alone, all right? Has to have a coefficient of 1. So I'm going to kick 2 out and have x squared plus 3x, and then this minus 13 is still going to hang out on the end. Now that I have my x squared, right, single over here, I'm going to use the formula b over 2 squared. Now, my b in this problem over here is 3. So I have 3 over 2 squared, which is 9/4. Now, you have to do this calculation every time. Sometimes it's going to be a fraction. Sometimes, right, you are going to have an even number there, and then it's going to be a whole number. It doesn't matter. So what do you do with this number? Well, this is what I call the magic number, which will complete the square inside the parenthesis. So you're going to have 2x squared plus 3x, and then you're going to add and subtract the magic number. Now, obviously, because I added and subtracted the magic number, right, I created here, let's go blue, what you call a completed square. You see, if you use that good old algebra, square root of the first, sine of the second, square root of the third, you are actually able to stuff it into a squared expression. If you FOIL this, you will get those 3 terms up there. So again, square root of the first, sine of the second, square root of the third. Now you still have 2 in front. And now here is the, the grade slayer. This 2 is multiplying all 4 terms. By using that 2 in front of the square over here, you took care of the first 3 terms. You did not apply 2 to the 4th term yet, because this 4th term was not in the group with the first 3 terms, which got condensed into a square. So this one still needs to be multiplied by the 2 in front, which is why it becomes 9/2, and then you have minus 13. So I'm going to actually now kill all these things here, and I'm going to do green, I guess, and I'm going to say that this 9/2 over here is 2 times negative 9/4. Negative 9/4. So hopefully you will pick up that 9/4 is that 9/4. Awesome. And all I need to do now is to add these 2 numbers and I'm done, right? So 13/1 times 2, blah, blah, blah. So 2x plus 3/2 squared. And then you have minus 9/2 minus 26/2. And there they are.
I don't understand how the magic number thing worked.
Oh, that's because of the formula. I can do the proof real quick. It's not a big deal. So y equals, there we go. And you can now see that you have your hk, right, given. That's -3/2 and -35/2. Ta-da! That's a 3 right there. Awesome. Now let's see what is happening and why the magic number worked. So when you are here, the only thing that you are considering is actually x squared plus 3x, right? So the standard formula, so we have x squared plus 3x. The formula for a plus b squared is a squared plus 2ab plus b squared. Now, if you consider your problem, you have x squared plus 3x. Now, if your a is x, then that knocks off that, and look what you got. You got 2b and 3. So if 2b is equal to 3, right, then b is 3/2, which was exactly what our formula was. 3 was b over 2. Now, why are you squaring it? Because you need it squared. Because that's the number that you added. That was the third number, this one. So you added the third number, and then you subtracted the same number, so you are not changing the value of the overall expression, and then used the first 3 as a perfect square, and then the fourth one was just multiplied by 2 and went away.
Okay, this is the part where I'm not getting it. I'm not So you're taking x squared plus 3x plus 9/4.
And that's this.
That's what. And so you're squaring that. So is x plus 3/2 just a simplified version of that?
I'm sorry, what x?
I'm not seeing how you're getting from x squared plus 3x plus 9/4 to x plus 3/2 squared.
Oh, that's the algebra factoring. So when you have the perfect square, they get condensed into this. That's from algebra when you work this when you're working this formula, the red formula, when you're working it backwards. So I mean, if you know the trick, you use the trick. If you don't know the trick, you can do the factoring from algebra. But the fact was x squared plus 3x plus 9/4, right? And now you are either going to factor this, or you know that when you have a perfect square, you can use the trick that I repeated twice: square root of the first, sine of the second, square root of the third, everything squared.
Oh, that's what you meant. Okay, square root of the first.
Sine of the
So the first
second,
one is square sine of the second.
and then square root of the third.
What do you mean by sine of the second?
Plus.
Oh.
Professor, at the top, when you were factoring out, can you go up a little bit where you were factoring out the original equation?
Right here.
Right there, yeah. Why, so do we need to keep inside the parentheses, does it have to be x squared?
Yes.
Because couldn't you have taken out like a 2x?
No, it has to be x squared because when you are working out later, it has to be they have to
squared?
match because the formula has
okay.
the a squared. So in order for the theory and the proof to work, right, it has to be x squared.
Mm-hmm.
So we are not factoring everything out and working that algebra. We are making sure that x squared is single because that would match the a squared, and then you're going from there. That's the only reason.
Oh, I see. Could you do an example without a fraction? Like a whole number?
Yeah, sure. you just get to learn less from
Oh,
there.
sorry.
Let's go. No, I'm going to do it.
No, I just usually
what's
like I
what's your
understand
favorite
better when
color?
it's a whole number.
What's your favorite
Black.
color? Okay.
Black.
Well, okay, fine. So we're going to take now. Let's go with 5x squared minus. Now, in order for this to, I can divide by 2. So 50 would do it, I hope. And then minus 7. Doesn't matter. Because, yes. Or we can, 50, we can put 40, we can put, let's put 40. So we don't have too many 5s around. There we go. So complete the square. All right, we start by blocking off this and kicking 5 out, so x squared is single. And now when you do b over 2 squared, you have 8 over 2 squared, which is 4 squared, and the magic number is 16. So in this case, we did not get the fraction. And you have your 5, x squared minus 8x. We add 16, we take away 16, and then we have minus 7. So here are the 3. You always add first because your formula, right, quadratic formula has plus b squared. So you have to always add and then subtract because this is the one that you will not use. So now we have 5 square root of the first, sine of the second, square root of the third, minus 16 times 5. That's 50 plus 30, 80, minus 7. So this 5 times negative 16 is 80. I know I have to write this one down because it's a grade slayer. And there you go. 5x minus 4 squared minus 87. Woohoo. So we have our h comma k to be 4 negative 87. And because the a is bigger than 0, it will open up. So we also know it's a minimum, right? Because because a is 5, right? We can write that actually. A is 5, which is bigger than 0. It's the reason why it opens up. And when the parabola opens up, it has the minimum on the bottom. So, woohoo.
Thank
And then that
you.
form we have at the
Yes.
bottom, what is that? What's that form called?
Standard form. This is the one. This is the new one that we seen.
So we
And
went from one kind of standard form to a different kind of standard form.
no, it went from ABC form.
Oh.
Right. This is the ax squared plus bx plus c. Right. The other one is called the standard form. This one is just quadratic function or whatever.
Okay.
So this is the conversion from ABC form into the standard form, and we have seen that standard form to ABC is a joke, right? Because all you need to do is to FOIL and add 4. I mean, FOIL, multiply by 3, and then add 4. So that's much quicker. The completing the square again. We'll be back in chapter 9, guys. So I hope that you will practice this thing, and here and there it pops up again in calculus. All right. So now we have another thing for the vertex, right? So vertex, which is h comma k, is we know that's either a minimum or a maximum, right? So we know that. If it's a minimum, the function looks like that. If it's a maximum, function looks like that, right? So min and max. And the vertex can be calculated using a function. So if your function f of x is equal to a x minus age squared plus k, well, in this case, we can just read, right? Just read them off because they're there. But if you have f of x equals ax squared minus bx, plus bx plus c, right? If you have that form, then your vertex can be calculated using the formula. So your age, which is the x-coordinate of the vertex, is going to be negative b over 2a. And this is what I used in 1.10, if you remember, to kind of find that point of a minimum and a maximum so we can figure out the price of the ticket. If you go back and watch that lecture again, right, you will see me use negative b over 2a. It calculates the x-coordinate. So if I have a vertex, right, so I have some function right here, quadratic function, and here is my age comma k. Right, so age is the x-coordinate and k is the y-coordinate of the vertex. See, the formula to calculate this age is this. And then you can calculate k as a function of negative b over 2a because you will get a number, right? That's going to be equal to 3, let's say. And then you just put that 3 in the formula and you compute k because the age is the x value, which is input, produces k, which is the y value, which is the output. So technically, age comma k can be also represented as negative b over 2a comma f of negative b over 2a. Now it's convoluted to write it that way, but when you have a problem, it's always a joke to compute. Find vertex for y equals 3x squared minus 4x plus 11. I don't care, right? So you go, my a is 3, my b is negative 4, my c is 11. No one cares about c because it's not mentioned in the formula, but you have it. So age is equal to negative b, so that's negative 4, divided by 2 times a, which is 3. So that's 4 over 6, which is 2/3. I got my input, x. So now, to find k, all I need to do is to calculate f of 2/3. Okay. 3 2/3 squared minus 4 times 2/3 plus 11. It's a basic arithmetic. One of the 3's will cancel. So you get 4 over 3 minus 8 over 3 plus 33 over 3 if you want the common denominator right of the bet. 29 over 3. That's a negative 4, right? 33 minus 4 is 29. So vertex is at 2/3 and 29 over 3. That's literally a point somewhere, and then you just go whoop whoop and you're done. So if you have standard form, you look at it and just pick your age and k. If you have the ABC form, you jump through hoops to calculate your age and k. So each of these forms of quadratic function has their perks and benefits and its drawbacks. And it's not one is better than the other because they are used in different situations. So standard form is awesome for graphing. We love it for graphing because you just look at it, you know your vertex, and you look at A and you say, oh, goes up or down. So it is a joke. right? If you need to graph and you have a standard form. It's a nightmare if you have to graph it and you have the ABC form, because you get nothing. You have to go find vertex or calculate points or whatever witchcraft you have to perform, right? To get the problem solved from that point. So graphing, amazing with one form, nightmare with the other. Great. Now,
Sorry, just to review one thing about this formula. So for K, we're doing the function composition of H, right? And we're just replacing.
it's not a function composition. You're plugging in a number. It's not a composition. See, this is like you can say f of 3, you can say f of 7, you can also say f of 2/3. 2/3 is a number. It's not a composition. I literally plugged in the number into x's. It's a basic, yeah, it's a basic day one. It looks like it's a composition, but this is not a function. This is a number.
Gotcha.
Right?
So you're just taking the number you get from H and plugging it in for negative B.
You get no. You calculate your age, and then you take that and you plug into a function to calculate k.
Yeah.
You have, yes. So you have
Gotcha.
right here. I mean, they're separated here, and they're put into a single point on the bottom because hk is a point, right? So x coordinate calculation and a y coordinate calculation.
So could you call it
You
f
get
of
your
H?
y when you plug in your x. Now your age is x, and when you plug that into the function, you get your y, which is k.
Gotcha. All right, thank you.
Awesome. All right, to go back to the story, right? We said it was great to have our standard form around because graphing is awesome. And it is nightmare to have ABC because graphing is terrible. But then on the other side, when you want to solve equations, you have a quadratic formula, right? And you just stuff everything into quadratic formula, where on the other one, you have to do more algebra. So, as I said, every formula has its perks. So, don't get to be like, oh, I like this one and I don't like that one. It's not what we like, we don't like. It is, this one is used in this situation, the other one is used in the other situation, and each one is better somewhere. So now, if we go back to our problem from 1.10, and we remember that we had that equation that said the revenue was, I believe, was 26,000 P minus P. What was that thing? There we go. 100P squared. 100P squared. Okay. So minus 100P squared. Minus 100P squared. There we go. All right. Now, first, I would like to put this in the ABC form because this needs to be first, right? So I can just call this f of x equals negative 100x squared plus 26,000x and then plus 0 because there's no c. P, price. R, revenue. Well, just x and y. Or I can actually put P back. Because it doesn't matter what variable you use, it is still the same equation. Now, what did we learn? We learned that, A is equal to negative 100. It means it opens downward. Well, we knew that because I did have this graph for everybody, right, that time. And I said that this is going to be your price, and this is going to be your revenue. So the company makes most money in revenue right there at the maximum of this function. But that happens for a particular price P. So by simply figuring out the x coordinate of the function, you actually get the price. This is how you make money. in what you would call a real world, because our class over here is a fake world, obviously. So, didn't we just learn that the age is negative b over 2a? So, negative b divided by 2a is negative 26,000 divided by negative 200. These zeros are going to get knocked off, and then your negative 260 divided by negative 2 is positive 130. So it seems that if you have 130 set as a price, you are going to have the most money made for that particular. If you remember, it was the airplane flying between my two locations. So if you set the price at 130, you are going to make the most money. Remember that they had the price at 200, and they said if you put 201, we're going to lose 100 people. Yeah. So if you set the price at 130, more people will come in. So you always have to play that game of price and value, and that's why, I mean, there are discounts and sales and all these kind of things. Just trying to, get the people in. Sell some tickets on inflated prices, but sell others right at the cost, and so on. So it's a game you play. But what's important is that we used mathematical modeling to come up with a function, and now that we learned quadratic functions, and we learned the formula for x coordinate of the vertex, this maximum has h comma k, but my h was price, and there was the best price for max profit. So best price for maximum revenue, actually, not profit. You can do the analysis from the profit standpoint as well, but you have to do profit is revenue minus the cost, because you have a cost of running the business. If you're an airplane carrier, right, you have to buy the airplane. That thing is millions of dollars. And then you have the cost of maintenance, and the pilot makes like $250,000 if it's the one that flies over Atlantic, right? Their salaries are $250,000 and on. That's 250,000 for I don't know what the $250,000 is. So there is a lot of cost to run, right? A lot of fuel, a lot of maintenance, the crew, salaries, right, and everything else. So it's not cheap, and you can figure out, right, the profit and all of that kind of stuff. But you have to start somewhere, right? So we start here, and then those of you interested, right, you go dig deeper and research. The last thing that I want to mention, since we have 3 minutes left, is that quadratic formula, which again from algebra, you just drag it with you, and I'm going to mention that that is used to solve quadratic equations. So quad equations, and those are of the form ax squared plus bx plus c equals 0. Or you can do the hk equals 0, doesn't matter. Now, if you're using this form, you can use quadratic formula, which will compute the values, and that's x12 is equal to negative b plus minus square root of b squared minus 4ac divided by 2a. So again, this is the formula you guys have seen in your algebra class, and now you get to use it. So 2x squared minus, let's say, 3x plus 11 equal to 0. You can't factor this. You can try, but it's not going to work, right? 2 times 11 is 22, and the factors of that are 1 and 22, and 2 and 11. And you can't use these numbers to make 3. So it can't be factored, which means you are stuck with quadratic formula. That's not bad. A is 2, B is negative 3, and C is 11. So I stuff those in and get negative 3 plus minus square root of negative 3 squared minus 4 times A, which is 2, times C, which is 11, divided by 2 times A, 2 times 2. And I just need to grind through PEMDAS, right, to get this. So that's 3 plus minus square root of 9 minus 88. Ooh, spooky. That's 3 plus minus square root of negative 79 over 4. Complex numbers. Yes. 3 plus minus I square root of 79, I'm just going to leave it, over 4. So now your x1, the first solution, is 3 plus I root 79 over 4, and x2 is 3 minus I root 79 over 4. Many of your problems will end up looking like this in homework and later on. This is not, oh, I picked the wrong bad numbers, so it didn't come out to be 7, right? Many of your homework exercises will look like this, where you can't take the root. Sometimes you can kind of help it a little bit, and right, if this was 72, you can write it as 2 times 36 and have a 6 root 2, right? So whatever witchcraft you know from algebra course, use it. But in many cases, there is no square root, and if there is anything we hate decimals. So, just, if it's not a perfect square, just leave it. If you can help it a little bit and get at least part of it rooted, do it, right? But you don't have to go into the decimals, because those are obnoxious 100% of the time. Just because they're always approximation, right? They're not exact value. So if we can have a nice exact answer, we're just gonna deal with square root of 79. The other thing here, guys, do you see the complex conjugate? Remember I said conjugate pair, plus and minus? These don't actually look like complex numbers until I write them as complex numbers. There you go. See? Now they actually look like complex numbers because you have your a plus minus bi, a number, and then I, a number, I. So they are complex numbers in this case. And they're complex conjugates because one is positive, one is negative. By the way, this is the proper way to... We all understand that that works, right? You're not going to fail the course if you put this down. It's just the matter of, right, you put in this form here to show off your knowledge. And that's quadratic functions. You know most of this stuff. We added formulas for Vertex. We did that completing the square procedure twice. We have seen also that they can spit out complex numbers now as the answer, where in algebra we are very careful not to have those. And again, quadratic function is just an intro to polynomial functions, because polynomials are now not going to be, oh, linear is x to the 1, quadratic is x squared. Now polynomial is going to be all of them. X cubed, x to the 4, x to the 7, x to the 16, x to the 1 million, right? So that's going to be next, which is next week. The homework for this will open, so I hope you guys will work on these concepts, and I'll see you next week.